Finally, I just want to leave you with a summary of the things we've covered, specifically focusing on emission lines and absorption lines, the Boltzmann and Saha equations, which we can use to predict essentially how electrons are distributed, and therefore to predict whether we will see emission lines or absorption lines. We also saw that lines are specific to each element. We can use them to identify the elements and to quantify the chemistry of, for example, a gas cloud. We've seen how shifts in wavelength from the Doppler effect can be used to infer dynamics, to see whether things are coming towards us or away from us, and also measure the radial velocity. And finally, we saw that different physics lead to different broadening of lines. And in some conditions, we can actually use the broadening to infer a temperature. But in many cases, especially when there's rotation that we can't really distinguish spatially, our emission or absorption lines may be broadened because of rotation of the object itself. I would really encourage you to go through all the questions at the end of section 5. There's even more than 4 normal sections because this section is really almost 2 and it's split in 2 parts. Some of the questions are quite advanced, such as those for the Boltzmann equation and the Saha equation, but I would still encourage you to at least read through the solutions to understand more about them. And if you're doing 264, you'll be able to apply them even more to other elements. And once you're done with the questions and you're confident that you know all about section 5, I would encourage you to move on to section 6, where we'll be talking about telescopes, some important considerations, different types of telescopes, and what really matters when we're observing through a telescope. So I'll see you for section 6.